Andrew Wood, and this is the Physics 2212 Lab 4 Circuits. Introduction. The purpose of this lab is to experiment with circuits and use our understanding of physics to predict what will happen in lab. This will be done using different capacitors, resistors, and methods of charge. This lab has no coding sections. Results. Because I performed this experiment online, the theoretical calculation and experimental calculations were the same. The RC circuit used in the experiment would have the current of the wire vary exponentially with time. Physics principles. The properties we will be using in this lab are the conservation of charge and energy, Ohm's law of voltage equals current times resistance, loop and node rule, capacitance, which is capacitance equals charge over voltage. I will acknowledge that we are using steady state and series/parallel circuits. First circuit, we will predict the value of current 1 and current 2 using Ohm's law. Because this is a series circuit, current 1 and current 2 are the same. This means that current 1 and current 2 are equal to 3 over 147, equals 0.0204 amps. When I create the circuit, both ammeters show current 1 and current 2 being 0.02 amps. This means my prediction was correct. When the connections are reversed on one of the ammeters, it still shows 0.02 amps. When an ammeter is replaced with a voltmeter, the voltmeter shows 3 volts, but the ammeter shows 0. This is because the circuit is not closed, so there will not be a current flowing through the circuit, but the battery still put off energy in the form of volts, which the voltmeter is measuring. Closed circuit voltmeter potential difference. A to B is 3 volts, B to C is 0 volts, C to D is 0.96 volts, negative 0.96 volts. D to E is 0, E to F is negative 2.04 volts, F to G is 0, and G to H is 0. The current measured is 0.02 amps. Using loop rule, we know that the sum of all potential differences should be 0, which matches the number I found. First circuit continued. Because the voltmeter has a very high resistance to the current takes the easier path and does not reduce the amount of current in the circuit by a measurable amount. This is also why the amp meter doesn't change its reading while the voltmeter is set in parallel with the 100 ohm resistor. Current equals 0.06 amps. This is because the amp meter offers less resistance than the 100 ohm resistor and takes the path of least resistance. Resistance of the 45 ohms resistor equals 0.96 volts over 0.02 amps equals 48 ohms. Resistance of the 100 ohm resistor is 2.04 volts over 0.2 amps equals 102 ohms. Resistance of the wire is 0 volts over 0.02 amps, which equals 0 ohms. And the resistance of the ammeter equals 0 volts over 0.02 amps, which equals 0 ohms. When connected to the battery, the bulb starts bright and decreases in brightness as the current decreases for the RC circuit. This is because the current decreases as the capacitor gets closer to full charge. When the battery is disconnected, the bulb starts bright again but fades to darkness as the capacitor discharges and there's no energy left in the systems. For the 10 ohm bulb, it took 10 seconds to charge and 12.5 seconds to discharge. For the 20 ohm bulb, it took 17 seconds to charge and 23 seconds to discharge. Data tables. The expected RC can be found by multiplying the capacitance times the resistance. That'd be 30 ohms times 0.2 farad, which equals 6 seconds. The expected RC can be found by dividing -1 by the slope of the graph, which was negative 0.1666, which equals 0.002 seconds. Errors. There are no experimental errors because I used a mathematical virtual model, so every measuring instrument and resistor is exactly what it says. The discrepancy in the RC time is likely due to the uneven measurements when I stopped this stopwatch manually. And the discrepancy in the resistance measured from the first part is likely due to the degree of inaccuracy that the ammeters had. What if I had used a real ammeter, because real materials all have some sort of resistance, the current readings between the two ammeters would be off and different from one another due to the lost current from the ammeters. Second what if. The virtual model uses wires and other parts that have no resistance, including the capacitor plates. But if this were performed in real life, the charging would take longer than the ideal scenario due to the resistance of the real-world objects. I'm Andrew Wood, and that was the Physics 2212 Lab 4 Circuits.